All right, on the warm-up, they want you to use the properties of equality to solve and check your solution. I specifically put that direction there because it will tell you whether or not you're solving correctly. These two problems were chosen specifically because we are confusing them. On the quiz last week, we either solved them both like number one should be solved, or we solved them both like number two, and we need to understand there's a difference between these two questions. Problem number one is x divided by 5 minus 6 equals 8. The entire side is not a fraction, which means I need to undo my addition or subtraction first. So on this one, we should be adding 6 to both sides to start, which leaves us x divided by 5 equals 14. Now I can undo my division with multiplication. So we should have gotten x equals 70. For those of you that got x equals 46, had you done your check, it would have told you it was wrong. It would not check. Here, when I do my check, 70 divided by 5 minus 6 equals 8. 14 minus 6 equals 8. 8 equals 8. It checked. If you had put 46 in, 5 doesn't even divide into 46 evenly, so it would have left you a fraction. Minus 6 would still leave you a fraction, which would not equal 8. That's why we should be checking our solution. You can know if you're right or wrong by simply doing a substitution and seeing if that answer makes a true statement. So on number one, we needed to undo our addition or subtraction first because it was separate from our division. In number two, we have negative 11 equals the quantity x minus 5 divided by 6. So in this case, to get to that x minus 5, I have to clear that denominator. So negative 66 equals x minus 5. Now I can add that 5 to both sides to get negative 61 equals x. And again, if we go in and check our solution, negative 11 equals negative 61 minus 5 divided by 6. Negative 11 equals negative 66 divided by 6. Negative 11 equals negative 11. It checks. So we have to understand the difference between these two problems, and the majority of us are still confused on the difference between these two. There are a few of you that did great, but the majority of us has struggled between these two types of questions and how do I solve them. Did you get the answer? What do you mean by differently? And then you what? You got the negative 66, so you multiplied both sides by 6, which is exactly what I did. And then what did you do? Okay, but if you just multiply by 6, you're at negative 66. You haven't, what did you do with the negative 5? Okay, but if I subtract, I wouldn't subtract negative 5 from negative 11. You're doing the opposite. You would have to add 5 to negative 11, which would be negative 6. And negative 6 times 6 would only give you negative 36. From negative what? But how did you get negative 61? Are you talking on the problem or the check? That's what I did first, was negative 61 minus 5. There's nothing to do on the left side. We're seeing, does the right side equal the left side? So we're not multiplying on the check. You're only working out the one side. So I did negative 61 minus 5, which is negative 66, and divided that by 6 to show that it checks. Order of operations, you have to complete the math in the correct order. So you did the exact same thing I did on the check. You did the order of operations. All right, so we've done solving one-step equations, solving multi-step equations, solving equations with the variable on both sides. Now we're coming back around to these absolute value problems. We're going to solve equations involving absolute value. Now that means we have to remember that absolute value is a measurement. It's asking us how far a number is from 0 on a number line. So when we're solving absolute value, there's two cases we need to think about. The expression inside the absolute value is positive or 0, or the expression inside the absolute value symbol is negative. And it comes down to, if I ask you the absolute value of negative 5, I'm asking you how far is negative 5 from 0. What would be your answer? 5. But what if I ask you the absolute value of positive 5? Still 5. So both of those give me a positive 5 answer. So when I'm solving, I need to consider that what's inside the absolute value could be negative or it could be positive to give me that positive value. So you're going to see we're actually going to have to solve 2, because the value inside can be positive or negative. So we have to keep that in mind. And they give us an example down here. The absolute value of D equals 3. So D could equal positive 3 or D could equal negative 3. And again, that's going to cause us to have to solve 2 equations at a time, because there are 2 possible answers here. So the other thing we need to be aware of is something called solution set. The solution set is the set of numbers that make an equation true. If we go back and use that D equals 3 or D equals negative 3, for example, my solution set here would be bracket 3 comma negative 3 bracket. So solution sets are always placed inside brackets. And then they are going to ask you on this in your homework to graph your solution set, and this is just simply going to be graphing the points. So in this case, I would have a dot at positive 3 and a dot at -3. That would be the graph of the solution set. Those 2 points, or those 2 values, make my absolute value equation true. So now let's take this to an example here and see, what does this all mean? So the first one, they're giving us the absolute value of y plus 2 equals 4, which means that y plus 2 could either be a positive 4 or a negative 4 to give us that positive 4 answer. So we're going to set up 2 equations. And when we set up these equations, the absolute value symbols are not part of these equations because we're just solving what's inside. So we're going to set up y plus 2 could equal positive 4, or y plus 2 could equal negative 4. And then we just go back and we solve both equations. So let's start with the y plus 2 equals 4. So just like we've been solving other one-step equations, I'm going to subtract 2 from both sides. So for this one, I get y equals 2. Then I have to go over and solve the second equation. So again, I'm subtracting 2 from both sides. Negative 4 minus 2 gives me negative 6. So y could be positive 2 or negative 6 to give us that positive 4. So that is my solution. Bracket 2 comma negative 6 bracket. Now, it does not matter what order the numbers are inside the solution set. If you had written negative 6 comma 2, that is still correct. It is still the same 2 values. And then it's asking us to graph our solution set. So at positive 2 and negative 6. That's what the graph would look like. All right, number 2 says the absolute value of 3x minus 4 equals negative 1. What do you notice as a difference between the problem we solved in number 1 and what they're asking me to solve in number 2? What difference do we see? Well, there is a number with the variable, so instead of 1y, we're going to have 3x. What other differences do we see? And besides, I know one of them uses y as the variable, one uses x. There is still one more big difference between the problem in number 1 and the problem in number 2. And it actually has to do with the other side of the equal sign. Number 1, they said it was equal to a positive 4. In number 2, they're saying it equals a negative 1. Can distance be negative? Can you show me a measuring tape that has negative numbers on it to go out and measure? So, because we know that distance cannot be equal to a negative number, I can't solve this. I can't go back. I have to have an absolute value has to be equal to a positive value. So here we would just have no solution. I cannot have an absolute value equal to a negative value. Because again, that what it's equal to is a measurement or a distance. And I can't have it equal to a negative. All right, problem number 3 on the next page. Now, before I can solve an absolute value, the absolute value needs to be the only thing on that side of the equal sign. The absolute value needs to be alone on one side of the equal sign before solving. So I can't start splitting it out into its two equations until I have just the absolute value part by itself on one side. So anything that is outside of the absolute value, we're going to use our properties of equality to solve. So in this case, number 3 says 2 times the absolute value of 3x plus 5 equals 16. So since this is 2 times, how do I undo 2 times a number? What is the inverse of multiply? Divide. So on number 3 here, I need to start by dividing both sides by 2. So now I have the absolute value of 3x plus 5 equals 8. Now I have the absolute value on one side, a positive integer on the other side. Now I can break it up into my two equations. So now I can say, well, 3x plus 5 could equal positive 8, or 3x plus 5 could equal negative 8. And now again, I'm back to my properties of equality on how I solve. I undo addition and subtraction first. So I'm going to start by subtracting 5 from both sides. So I get 3x equals 3. And then I have to undo my multiplication. Divide both sides by 3. So x could equal 1. Now I have to go back and solve the second equation. I'm going to subtract 5 from both sides. So 3x equals negative 13 because I have a negative 8 minus 5. And again, I'm going to go in and divide both sides by 3. So x equals negative 13 thirds. Now, for graphing, it's easier to graph if we turn that into a mixed number. So what is negative 13 thirds as a mixed number? Remember, it's negative, so it's negative 4 and 1/3. And again, that's just to help you graph to know that we have to go past the -4. So our solution, I'm actually going to use the improper fraction. So I'm going to do 1, -13/3. Now we need to graph. So again, 1, I marked +1, and then -4 and 1/3. Number 4, the absolute value of 2/3 x minus 3 equals 6. There's nothing outside of the absolute value, so I don't have to move anything. So here I can go into setting up my two equations. 2/3 x minus 3 could equal +6, or 2/3 x minus 3 could equal -6. Again, so I'm going to use my properties of equality. I'm going to use my addition property of equality here that says I can add the same thing to both sides. So it was a -3, I add 3. So I get 2/3 x equals 9. That is 2/3 times x, so I'm going to divide by 2/3. So I have x equals 9/1 divided by 2/3. But what do I do with fractions? I don't really divide. What do I do? Multiply, but what else do I have to do? Because I don't just change the division to multiplication. There's one other step in there. I have to invert that the second fraction. We invert and multiply. So this becomes x equals 9/1 times 3/2. Now I do multiply numerator to numerator, denominator to denominator. So I get x equals 27/2. What is 27/2 as a mixed number? And again, this is just for graphing purposes. We could leave it, we'll leave it as 27/2 for our solution set. But so I can graph it. What is What is 27/2 as a mixed number? 13 1/2. Now we need to go back and solve the second equation. So again, I'm going to start by adding 3 to both sides. So 2/3 x equals -3. Then again, I'm going to go in and divide by that 2/3. So I have x equals -3/1 divided by 2/3. And again, because we invert and multiply, x equals -3/1 times 3/2. And again, I'm going to multiply numerator to numerator, denominator to denominator to get x equals -9/2. What is negative 9/2 as a mixed number? It is not 4 1/2. Negative 4 1/2. We have to be careful with our negative signs. They don't just disappear. So our solution is 27/2, comma, negative 9/2. Now, our graph here is not big enough for the difference. So I'm going to kind of break it up. I'm going to do the negatives here. And then I'm just going to kind of do a squiggle line and then do the larger side of the graph there to show that there is a gap here. So negative 4 1/2 and 13 1/2. Number 5, 3 times the absolute value of x plus 4 equals 11. Now I do have things that are outside of the absolute value on the same side. So I need to start by subtracting 4 from both sides here. So 3 times the absolute value of x equals 7. And then that 3 is still outside of that, so I need to divide both sides by 3. So the absolute value of x equals 7/3, which means that x could equal positive 7/3 or x could equal negative 7/3. Now, because it's just x inside, I don't have any other solving to do. But what is the mixed number for 7/3? 2 1/3. Which, because this is just the negative version, this would be negative 2 1/3. So our solution, 7/3, comma, actually I'm right. Comma, negative 7/3. Now, there is another way to write this because they are the same number, just positive and negative of the same thing. Sometimes you'll see solution set, and then they will stack the plus and minus underneath each other, and then just write the 7/3 there. So those two solution sets are saying the same thing because this plus minus here reads as plus or minus. And again, I just want to show you that when you get into Math 2 next year, you see that notation a lot more when you get into quadratic functions, that positive and negative. All right, now we have a word problem with this. Skydiving. It takes approximately 6 minutes for a skydiver to land after she jumps out of a plane. Give or take 30 seconds. What is the range of time in seconds it could take the skydiver to land? So it's very important. They're asking for our answer in seconds. They gave us part of the problem in minutes, part of the problem in seconds. We need 1 unit of measurement. So we're going to convert minutes to seconds. So you do have to pay attention in word problems if they're not in the same unit of measurement and look for what are they asking. So we know that 1 minute has how many seconds? So then 6 minutes would have 6 times that 60, or how many seconds? 360 seconds. Now they're asking us the range of time in seconds, so we're going to say let x equal the range in time. So that we know that it's around 6 minutes, but we want to know the range, that 30. So this would be the absolute value of x minus that 6 minutes, or minus that 360, is equal to 30. So now I have two problems to solve. X minus 360 equals positive 30, or x minus 360 equals negative 30. So I need to add 360 to both sides. So for this first one, we get x equals 390. Go to the next one, we add 360 to both sides. X equals 330. So it could take from 330 seconds to 390 seconds to land.